Hello, students. So, what we're going to start in on here is another philosophy about trig functions. I'm going slightly out of order as compared to the order that the book does things, but that's just kind of the way it has to be. So, what is this new other philosophy? So, the philosophy is maybe even well motivated by the fact that it's called trigonometry, which suggests that it has to do with triangles. So let's try to translate all of the stuff we know about triangles, trigonometry, into triangles. Right now we know it about unit circle. So let's just remember the definition of trig functions. So here's a right triangle drawn inside of a unit circle. Let's just fill in some things. So I've started at 1, 0, because this is a unit circle. I've rotated forward by an angle of theta, landing at a point x, y. So this x is exactly cosine of theta, that y is exactly sine of theta. So with that out of the way, let's start reading things off. What is the length of the hypotenuse of that red triangle? Well, this is a point in the unit circle. So the distance from 0, 0 to the point xy has to be 1. So the length of this edge must be 1. So it's the hypotenuse of that triangle, 1. What's the length of the edge opposite theta? So let's color code a little bit. So let's look at that triangle. I want to know what this side length is. Well, but notice that side length should be exactly that y coordinate. Right? That side length is how far above the x-axis is that point. So this that side length is exactly y. But what is that y coordinate? It's a trig function. It's the sine of theta. Similarly, the base of that right triangle, the length of the side adjacent to theta, is exactly the x-coordinate, which is cosine of theta. All right, so now I want to rescale this triangle. So what if I rescale this triangle, I double every side length. Now suddenly this side length has length 2. This side length is now 2 times cosine theta. This side length is now 2 times the sine of theta. Maybe I'll put that there to remind you that this is still a right triangle. So let's just write those down. What's the length of the hypotenuse of this triangle? 2. What's the length of the edge opposite? 2 times the sine of theta. What's the length of the side adjacent? 2 times the cosine of theta. All right, so that's what happens when you rescale everything by a factor of 2. What if you rescale everything by a factor of h, where h is some positive number? I don't want to rescale by -7. I don't want to rescale by 0, otherwise I would collapse the triangle to a point and there would be no information left. If I do that, you rescale every side by a factor of h. Now this side, the length of the side opposite, right, originally it was the sine of theta, but I multiplied it by h. H times the sine of theta. The adjacent side is now h times the cosine of theta. Filling all these in, what's the length of the hypotenuse? It's h. What's the length of the side opposite theta? It's h times the sine of theta. What's the length of the edge adjacent to theta? H times the cosine of theta. And I'm going to box those because they'll be important for the next line. Do you think you could take the red one and solve that for the sine of theta? Yeah, of course you can. You would divide... when I say solve, there better be an equation, which implicitly there is. H times the sine of theta is equal to the length of the side opposite, h times the cosine of theta, is equal to the length of the side adjacent. So you could solve that red equation for sine theta, and you would wind up with the fact that sine of theta is the length of the side opposite divided by the hypotenuse. Similarly, the cosine of theta, you could solve the blue boxed equation for cosine of theta. You'll get adjacent divided by h. Let's make that h look a little bit more like an h instead of an n. So the cosine of theta is the length of the side adjacent to theta divided by the hypotenuse. And if you know sine and you know cosine, you can figure out tangent. Tangent is equal to the sine over the cosine of theta. And let's just use what we know. Sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. So when you divide both the numerator and denominator by the hypotenuse, those two things can cancel. So you're left with just opposite divided by adjacent. So the payoff is the tangent of an angle theta can be computed by looking at any right triangle where you see the angle theta and computing the length of the side opposite and dividing by the length of the hypotenuse. And these are three facts. One tells you what cosine is, one tells you what sine is, the other one tells you what tangent is. There's a single mnemonic that's useful in remembering all of them. It's just a mnemonic. If you can remember 3 syllables, you can remember this. If you can remember the syllables so, ka, toa, then you can remember these 3 facts. So that mnemonic is just saying sine is equal to the opposite divided by the hypotenuse. Cosine, ka, is equal to the adjacent divided by the hypotenuse. Toa, tangent, is equal to oa, opposite, divided by the adjacent side. So that's all well and good. Let's start trying to use this to solve some right triangles. What does solve mean? Well, to solve a triangle means you determine all of the side lengths and maybe even all of the angles in that triangle. Yeah, let's get all the angles too. So here's a right triangle. So it's a right triangle, so that is a right angle. Let's try to find all of the side lengths of this triangle, and let's try to use that to determine all of the trig functions of this angle, theta. So let's do that. Step 1, figure out the length of the hypotenuse. Well, we have the Pythagorean formula for right triangles. The length of the hypotenuse of a right triangle is the sum of the squares of the other two sides. So h squared is 4 squared plus 3 squared. That's 16. 4 squared plus 3 squared is 9 is 25. Oh, and so h squared is equal to 25. So that means h is equal to, well, maybe I'll be a little bit silly, plus or minus the square root of 25, also known as plus or minus 5. But this is the side length in a triangle, so it doesn't make sense for it to be negative. It has to be positive. The length of the hypotenuse is 5. Now let's compute all of the trig functions of this angle theta. So, cosine of theta first. So ka toa. Well, maybe we'll do sine because so comes first in so ka toa. Sine will be opposite over hypotenuse. Sine is opposite over hypotenuse. Here's the angle theta. There's the side length opposite. So the opposite side length is 4 divided by the length of the hypotenuse is 5. Sine of theta is 4/5. Cosine, ka, so ka toa. Cosine is adjacent divided by hypotenuse. The adjacent side to this angle is 3. 3 is next to the theta, so it's adjacent. So you wind up with 3 over hypotenuse is 5. Tangent, TOA. Tangent is opposite over adjacent. Opposite, adjacent. 4 thoughts. Nice. So the remainder of this packet consists of some applications of this idea, which involve using a machine to do some computations, which I encourage you to do along with me. So I think that I will stop this video here, and we'll come back to the next one and start doing some applications.